July 2025, astronomers, poised to track a newly discovered interstellar comet, were ready for just another cosmic blur streaking across their screens. But what they found instead wasn't just unusual, it defied every rule in the book. The object, named 3I Atlas, wasn't behaving like any comet ever seen. Comets are supposed to have tails that point away from the sun, pushed by solar wind and radiation, but this one was different. It was firing a focused narrow plume of material straight toward the sun. This bizarre jet was creating a steady, measurable push, as if some hidden engine was at work, defying the fundamental laws of celestial mechanics. Its chemistry was alien. Its course through our solar system was almost too precise to be believed. And its speed, a staggering 135,000 miles per hour, forced experts to tear up the textbook on visitors from beyond. If a comet can behave like it has a propulsion system, something long considered impossible, then what exactly is 3I Atlas? And more importantly, why does its sunward tail have the world's top scientists so completely rattled? The story begins on July 1, 2025. The Atlas telescope in Chile flagged a tiny, moving speck that didn't match any known object in its vast catalogs. Within minutes, an automated alert pinged the operators. This wasn't just any space rock. It was blazing across the sky at 61 kilometers per second, on a path that no object belonging to our solar system could possibly follow. Immediately, internal emails and Slack channels at observatories worldwide lit up. The first orbital calculations confirmed their suspicions. The trajectory was hyperbolic, a wide open curve that screamed interstellar interloper. This visitor wasn't just passing through. It was a messenger from another star system. Researchers frantically searched archival data and found faint traces of it in earlier images from mid-June, confirming its strange arc. Each new data point tightened the orbital solution. It was inbound from the direction of Sagittarius, slicing through our solar system at a shallow angle, just 5 degrees off the main planetary plane. This precision alone was stunning. Most comets drift in from the distant Oort cloud, but 3I Atlas was moving faster than any comet in recent memory. Its trajectory was set to carry it on a tour between Earth and Mars by late October. While it posed no threat to us, it was simply impossible to ignore. A routine discovery had escalated into a global astronomical alert. On July 21st, the Hubble Space Telescope turned its powerful eye toward the mysterious object. Imaging specialists gathered, expecting to see a classic comet. What they saw on their screens, however, was shocking. The raw images revealed a distinct, narrow plume arcing directly toward the sun. The expected anti-solar tail, the one all comets are supposed to have, was faint, almost an afterthought. Independent observations from the Gemini South Telescope in Chile confirmed it. This wasn't an error. Analysts checked for instrument artifacts, recalibrated their filters, and meticulously ruled out any background stars. The sunward plume held steady in every image. A persistent, unwavering jet. The astrometry teams then mapped the object's motion with incredible precision. The numbers just didn't add up. There was a subtle but consistent deviation from a purely gravitational path. An extra push, an anomalous acceleration, was acting on the object. And its direction lined up perfectly with that sunward plume. This wasn't random outgassing from a tumbling chunk of ice. It was a continuous directional force. What could possibly create a comet tail that acts like a rocket engine, pushing against the force of the sun? Simulation experts at the University of Maryland ran the numbers. To produce the measured acceleration, 3I Atlas would need to be ejecting mass at a rate of over 300,000 kilograms per second. That's the equivalent thrust of a small rocket, not a quiet comet. Yet, when astronomers measured the actual dust and gas coming off the object, they found it was losing at most 1 kilogram per second. The gap between the force required and the material observed was staggering, a factor of at least 10,000. No known natural phenomenon could explain this discrepancy. Then, the James Webb Space Telescope delivered another piece of the puzzle. Its powerful spectrographs analyzed the chemical makeup of the plume. The results were just as strange. The coma was overwhelmingly rich in carbon dioxide, outstripping water by a ratio of 8-to-1, a complete inversion of a typical comet's recipe. But the real shocker was the detection of atomic nickel. On Earth and in meteorites, nickel and iron are almost always found together, like cosmic siblings. But in 3I Atlas's plume, the nickel stood alone. There was no iron. The team triple-checked their data. The bizarre signal was real. Every standard model failed. The physics didn't work, and the chemistry was from another world. The evidence was mounting. Something was pushing 3I Atlas toward the sun with a force that nature, as we know it, has never produced. They ran millions of simulations of interstellar objects arriving in our solar system. The odds of a random object arriving on a path just 5 degrees from the ecliptic, our solar system's flat plane, were less than 1%. But 3I Atlas's path was more than just low angle. It was an almost perfect tour of the planets. It would perform close flybys of Mars, Venus, and Jupiter, all in sequence. This brought back memories of Oumuamua, the first interstellar visitor from 2017. It, too, had a puzzling acceleration and hugged the ecliptic plane. But Oumuamua was a silent, tumbling shard that revealed no plume. 3I Atlas, in contrast, was broadcasting its strangeness with a visible jet and a trajectory that felt, well calculated. A fierce debate ignited in the scientific community. Was this just a cosmic coincidence, a 1 in a billion statistical fluke? Or could the path itself be a signal? An engineered demonstration designed to see if anyone was paying close enough attention to notice the rules being broken. The clock was ticking. On October 30th, 2025, 3I Atlas is scheduled to sweep behind the sun. For several weeks, it will be completely lost in the solar glare, creating an unavoidable blackout for every telescope on Earth and in orbit. This is the moment of truth. During this period, when it's closest to the sun, any change in its speed or direction will go completely undetected. As the world's telescopes prepare to fall silent, speculation is running rampant. Some theorists suggest it could be a Bracewell probe, an autonomous robotic sentinel, designed to find and signal intelligent life. Others wonder if the nickel-rich plume is a form of purposeful dispersal, a way to seed planets with specific materials. Perhaps the most intriguing idea is that the object is an interstellar IQ test, its physics-defying behavior a deliberate challenge. Of course, darker theories have also emerged, whispers of it being debris from some distant, unknown conflict, its engine damaged but still firing. But everyone agrees on one thing: the real test comes after the blackout. In December 2025, when 3I Atlas is expected to reappear, the world will be watching. If its trajectory has changed in a way that solar gravity alone cannot explain, the debate over whether it is natural or artificial will enter a new and frankly terrifying phase. For now, 3I Atlas remains the most perplexing visitor our solar system has ever received. A cosmic enigma that challenges our most fundamental understanding of the universe. What do you think it is? A natural wonder or something more? Let me know in the comments. Thanks for watching, and if you enjoyed this journey into the unknown, don't forget to like and subscribe for more deep dives into the mysteries of our cosmos.